Okay, this video is in support of 1200, and it is the second half of the Sprites for Processing presentation that we started last week, and you should read this or watch this video sometime during the week of the 10th. Okay, so where we left off was the idea of key processing. So to have the game, to use this game, we need the capability to detect whether or not a key is pressed. So we, looking at the example SB12, right here, let me start it, SB11, and we'll run it. And so I'm pressing I have to give it focus, so I click on the window, the canvas, and then I'm pressing the up arrow. When I have the up arrow pressed, then we do the acceleration and show the second image. When the up arrow is released, we of course stop the acceleration and use the other frame, the first animation frame. So we just need to know, we need a mechanism that can determine whether or not the key, particular keys, are currently pressed or released. And that doesn't come with, that facility doesn't come with standard processing. And so to make that work, we use the keyboard controller, which uses that Game Control Plus library that's giving us some headaches on Apple M1 Macs. But at any rate, let's look at the slide. All right, so process keys. Let's look at that again then. So here in process keys, we have, now this is pretty much identical. We have this mechanism for getting the device, keyboard as a device, and again, this is in the change that we made to make the processing Asteroids game work on an Apple. We had to change this name, had to change this value here. According to the instructions, I'm running on a PC, so I have a Windows PC. I have the defaults. And so we essentially, you don't have to understand this completely, but there's a function provided by this keyboard controller, which called isUp, and it just returns a Boolean, true or false, determined by this function provided by this control, processing control, Game Control Plus library. So this returns true if the up arrow is pressed, false if it's not pressed, true if the down arrow is pressed, false otherwise, and the same for each of the other keyboard buttons that we've configured here in this keyboard control. It's called a constructor method or initialization. So with that in mind, if we look at our code here in setup, we don't really seem to do anything. If we in pre though, remember pre is this function that will be called before draw. So again, the draw loop is as mentioned earlier in this set of slides. The draw loop becomes call pre, call draw, call pre, call draw, around and around. And if you don't remember this is covered in one of the earlier slides for this presentation. This is necessary, focused, is built-in function. Yeah, right, make sure. Yeah, it's a built-in processing function that is true if the window has focus. So if I start the processing game again and I have this has focus, then the arrows, don't do anything. Well, they're doing whatever they require here. If I give the Explorer window focus, then the arrows don't do anything. But if I have focus on the window, then the arrow, then everything works as expected. And so that's what focus is about. It's just testing if the window has focus. And if it does, if it's true, then we call process keys. So here we're doing something for the up arrow. So Again, this is calling that isUp method on the keyboard controller, which we've configured, described. And so if isUp returns true or is true, then we set the frame to 1, which is the acceleration frame. And then we give the ship a certain amount of acceleration at this direction, which is just, the direction of the ship minus 90 degrees. I don't know why we had to do this, but anyway, this is just code. This is just something you have to do to make it work. And the subtraction. And so we give the ship acceleration. And it speeds up. So we both play the animation. We select the frame with the frame with the flame, and then we also, give acceleration to the ship in that direction that essentially the sprite has been rotated. Okay, if the up arrow is not pressed, is an if and then an else. If it's not pressed, then we set the frame back to the idle, the first frame without the flame, and we set the acceleration to 0 so the ship will just coast along. All right, so that's the up arrow if pressed, if not pressed. Then we also test the left and right arrows. So if the left arrow is pressed, remember this happens every time for every here in the pre function calls process keys. So this happens for every frame. Is the left arrow pressed? And if so, we increase, actually decrease counterclockwise the direction of the sprite with this direction. And then we set the ship's rotation. This is the ship sprite again, and it has a set rotation, and we set it to that rotation. And if it's the right arrow, we rotate clockwise, and that will, basically increase the direction and set the rotation. So that is, all that is necessary. Then again, so how does it all get drawn? Here in the draw function, we clear the background, setting it to that background image, and then we call this utility function S4P draw sprites, which causes the sprites to be drawn at their new position according to their physics and whatever settings we manually set or explicitly set in the pre-function. Okay. And again, notice to use that I shouldn't have to do this, but just to make sure it's clear, we are using ships2.sprite. It has 2 frames, frame 0, frame 1, and that is the frames that are being set in set frames and are being set right here. Frame 1 when we're accelerating, frame 0 when we're coasting. All right. Here's the code again. Okay. So remember we had these 2, I just covered draw sprites, but if we go back and look, I did mention in pre, after we do our update the state of the game, we call update sprites. So again, this is kind of boilerplate code. Remember that in pre, we must, at the end, we must update the sprites using that utility function, and it's again in draw, we update the sprites. Now we're doing it early, we're not doing it last, because we then want to draw the rectangle and draw the text, which I'm going to talk about next. Okay, so not only can, we can, much of the emphasis of this, what am I doing? Much of the emphasis of this section has been on how to use the sprites library to draw things. But we also want to, or need to, or want to draw text on the screen. And we also will want to draw, use raw processing, processing's basic or primitive drawing capabilities to draw rectangles and shapes and ellipses. We talked about that, showed that a few weeks ago. And so we are, as you can see, we're updating information about the ship sprite and printing it, and we also are rotating a rectangle, drawing and rotating a rectangle at the same angle as the ship's angle of direct rotation. And so to see that, we have two functions that are being called in the draw function down here, draw rectangle and draw text. So draw text is pretty straightforward. We're creating a message. Maybe I'll move this around a little bit. I'm not sure why. That'll work. Actually, that may be a little clearer. So we're creating a string text, and we're appending messages to it. Oh, we're setting the color of the text. And we're setting the font size of the text to 20 points, and then we're creating a message. And by speed, and then we're getting the speed of the ship. This is the ship sprite again, and it has these three properties: get the current speed that the sprite is moving at, get the position of the X position of the sprite, and get the Y position of the sprite. And then we're using a text to print that string at X equals 10, Y equals 40. And then the next line is at Y, or the horizontal vertical position 65 and 90, which gives us this positioning at 40, 65 and 90, I believe. And then we're updating the got to get focus. Have to update. Just reading the position of the ship as it changes over time. I think you see what we're doing. And then also we want to draw shapes, use trim. So here we're drawing a rectangle. And this is a bit complicated. This is something that using these translation and rotation operations, the way processing does, is a little bit complex. And I'm not going to go into it here. We could talk about it later. But this is what's necessary. So fill is sending the color, which is yellow, red and green. I was setting red and green on. This gives us a yellow, and then this push and pop matrix, allows us to make a change to a particular draw operation and restore make a change to the translation and rotation, and then draw the shape, and then restore the translation rotations to whatever they were before we started making changes. This is very similar, in fact, as little as I know of it, to how OpenGL, how 3D applications perform the same operation. I'm not going to go into it, maybe discuss it later, but if you're interested, and you should maybe take a look at the documentation for these operations, and it should give you a good idea on why this seemingly complex process of pushing, translating, rotating, drawing, and then popping is needed to implement this rotating rectangle. The point is to keep the rectangle at a certain location when it's being drawn, but rotate it around its center. And it's a little bit tricky than it looks. And that's all I'm really going to say about it. Okay, so that's how SB11 gives a couple of examples of how to use the keyboard controller to detect when keys are pressed. Give a pretty good example of how the acceleration works, how to draw text and how to draw primitives in conjunction with the sprites for library, sprites drawing capabilities. I think so. Okay, there's something not really shown, but we'll talk about it later. Not shown in any of the examples, is sometimes we want to know if a sprite has left the canvas. And this is necessary for the missile. So if you can imagine, we'll talk about this later, but the missile when we fire a missile and it leaves the canvas, because it's moving along a certain direction, it'll eventually leave the canvas. And when it leaves the canvas, we want to know that that sprite has left the canvas, and then do something about that. So it's kind of a logic decision. Is the sprite still on the canvas, or is it on the screen? Now I know that this is misspelled, and we'll talk about it later. But that is just the API, and so actually I think this might have been fixed, and the screen is the slide's out of date. Either way, we'll describe this capability of determining if the sprite has left the screen when we get to the discussion of the processing game. All right, next slide. Now we need to know if two sprites have collided in two circumstances. We want to know if the ship sprite collides with an asteroid, which will cause them both to be destroyed, and the player, loses a life, and that's how the game works. If you lose 3 ships, the game ends unsuccessfully. And also between the missile and the asteroids. If we fire a missile and the missile sprite is moving across the screen, we want to determine if a missile has intersected or is touching a asteroid sprite, and then blow up the asteroid and missile. And we'll talk about the application logic later. So the collision detection is provided by the Sprites library. And second. So there's capability to determine whether the two sprites have collided. And what happens is, if they do collide, we're going to set the in this simple example, SB12, we're going to hide the sprite, set it to hidden. So let's look at that program, SB12. And we'll run it. And so, oops, it happens pretty quick, actually. So, we are testing every draw loop and every pre-function. We are testing to see if the two sprites have intersected, and there they do. When the ship intercepts an asteroid sprite, when the ship sprite intercepts an asteroid sprite, we make the asteroid disappear by setting it to dead. So let's look at that code. I think I have it right here. No, let's look at here. 1 second. Look at my slide. Well, let's look at it on processing. So here we have setup, just the usual thing, building the ship, building 3 asteroids. So here's 3 asteroids, kind of straightforward. So we're building the ship, and we're setting its position at the center of the canvas. And here we have that functionality embedded into this function build ships, which is in here someplace. I guess I haven't passed it. Build asteroid, build ship. XY position. So you can see how, looking at the previous material in these slides, you should be able to understand how we build a sprite, set its position, rotation, and so on, and then set a bounding box or domain for it to keep it within the screen. And then we want to build 3 asteroids. If you remember, when we start the game, there's 3 asteroids are running. So we have another function, build asteroids, and it has the same basic logic. We build a sprite using the small asteroids image, and this is how many images, how many frames are in the sprite. So it's small asteroid.png. Let's see what that looks like. Small asteroids. So we have small asteroids because we want the asteroids to appear to be rotating. And so I think they do that in the, let's have a look at the game running. Let me drag that over there. Be able to run it. Well, they're not rotating in this example. So later on in the actual asteroids game, the asteroids rotate, and they rotate by using these three, or they give the appearance of rotating by three different images. But we'll see that example in the when we talk about the game. So coming back on, looking at setup, we build first, the second, and the third asteroid, and we maintain a list of asteroids right here. So this is a list, like an array, but a list, something a little different, and we add those, we create an asteroid and we add the asteroid to that list of asteroids. Okay. Then in pre, we process keys, just like before. We determine if it's here in the function is here, process keys. We want to determine if the ship is accelerating, if it's going to rotate left or needs to be rotated right, just as we explained a few slides ago. So going back to pre, so we process the keys if the window has focus, if the canvas. Then we have a new thing, check collisions. That's right here. So what we're going to do is we have a list of asteroids, 3 asteroids that we created and initialized here, add to this list asteroids. So now I'm going back to check collisions. And if the ship and the asteroid collide and the asteroid is visible, so we only want to set the asteroid to change it to invisible or remove from canvas if the asteroid is not dead, meaning it hasn't participated, is alive, essentially, and if the asteroid, right here, and this is the asteroid sprite, is collided with the ship sprite. So this is going to say, this I could have done the opposite. I could have said ship collide with asteroid, but I did it this way. So if the asteroid sprite is currently collided with or is touching the ship sprite, then this returns true. So if the asteroid is still visible, that is, the asteroid is not dead, if the asteroid is still visible, and the asteroid and ship have collided, then we set the asteroid sprite to be invisible by setting its property dead to being true. So if the sprite is not dead, it's visible. If it is dead, by setting to dead, it's true. So after an asteroid has been collided with, its property dead will be true, and this will always return false because, not true is false. And so it won't set the asteroid to dead twice, is really what it amounts to. Okay. What does this get called? Excuse me. I don't think I'm using this in this example. I know I'm sounding like I'm, excuse me. Oh, here, I can reset. I didn't realize that. If the game had that capability. So let's run it again. And so if I hit R, we reset or randomly place the asteroids. So that's kind of interesting. So once, that's interesting. Yeah, I'm holding on the R key. Okay, so that's another functionality that we could demonstrate here. I did notice. So anyway, but again, see the asteroid touches the ship. Now it's not quite perfect. You'll see that the asteroid doesn't quite touch it, but it still disappears. And that has to do with the different type of bounding boxes, that different type of collisions. Let's see, the code is using where is in check collisions. CC collision, which is collision circle. Anyway, we'll talk about a little bit before different types of collision options, but right now we're just using a circle collision, and we'll come back to that before. We're using a circle mechanism to check if the two sprites are overlapping. Okay, but that's how we test. Oops. So when certain sprites collide, the game needs to execute certain behaviors. The behavior of the ship colliding with an asteroid, the behavior of a missile colliding with an asteroid. We don't have missiles in this example SB12, but on the next slide is an example of how collisions between ships and asteroids are detected and processed. You can read as well as I can. And this is essentially the code I showed you before. The for each pre-function, each time before each frame is drawn, we call this function, and this function will check each asteroid. Remember, asteroids is a list of asteroids. So each asteroid sprite in this list, we check to see if the asteroid is visible by being not dead, and we check to see if that asteroid is if the asteroid is collided with the ship, and if that is both are true, then we set the asteroid's dead property to true, which again makes it invisible, removes it from the canvas. All right. Also noticed that in the game, I am using processing's native key handler. So here we have in key pressed. So remember, key pressed is evaluated. This is an event handler, a key press event handler. So this function, key pressed, is called by processing each time. In this case, each time a key is pressed, regardless of which keyboard key it is, this is not mouse buttons. So anytime a keyboard key is pressed, this function is called, and then we test to see if that key that was pressed is R. And if it is R, then we call the function rotate asteroids, which basically right here are reset asteroids. Sorry. So reset asteroids will iterate through that list of asteroids and will set the X and Y position of the asteroid sprite to some random position between 1 and an integer between 1 and the width of the canvas on the X and 1 and the height of the canvas on the Y. So that's what we're doing here, getting a random X and Y position, set the asteroid sprite position to that X and Y, and then we set the dead property of that sprite to false, which shows it displays it on the canvas again. And again, we do this for loop. That means we're iterating through each asteroid in this list of asteroids and setting its position and making it visible. So if some blow up, boom, boom, hit R. Oops, no focus. Hit R, and they are. That calls that function. All right. Okay, frame-based animation. Slide 13. SB13. Right, SB13. Run it. So now this will show how we use frame-based animation. So whenever the ship asteroids touch, we now play an animation. We play a frame-based animation. And so that is accomplished by using another sprite. The sprite being explosion.png right here. So notice that we have a 1, 2, 3. Oops, sorry, you can't see that. My bad. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 frames in this animation. This frame is empty, but it still counts. It doesn't print anything, and then it shows, as you can see, in a animation. And when an asteroid blows up, that one, what's the other one? 12. Let's get rid of that one. When the asteroid blows up, it plays that animation once in sequence. See? So frame 1 through frame 9, or frame 0 through frame 8, is being played where the asteroid was, and then the only once. And again, it's a frame-based animation. It gives us the impression of movement. If there were more frames, the explosion would have more fidelity, but it is what it is. Also, another example is just this little guy down here slowly stepping through a series of, let's see what his looks like. Where is he? Oh, right there, walking. So here's an animation guy walking 1, 2, 3, 4, 5, 6, 7, 8. So here's 8 frames that we loop over and over again. Now we're doing it very slowly to give you the idea of how it works. Look at the code briefly. All right, let me see here. I haven't looked at this carefully. So we're going to in setup, we set the frame, we register the function pre, we load the background and a sound player, and then we create 3 asteroids. We create the ship, and we add 3 asteroids at these positions, and then we initialize walking guy. Build ship is just what we saw before. Build asteroids is the same as what we looked at before. Build walking guy. So walking guy uses the walking.png, and we set the walking guy's position to be in right here, 50 negative, the height minus 100, puts it in the lower left-hand corner, and we set its dead property to false, so it's visible, and then we have a property called speed that we set to 1. And then we use the speed to set the frame sequence 0 to 1, frame 0 to 7. Remember, there's 8 frames in that image. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so we're going to play through 7 frames, as you can see, and then we loop. In fact, there's a little bit of a glitch there, you can see. I'm not sure. I think I picked this off the web someplace. You see his heel kind of extends out there, so that's a bit of a problem with the way the frames were laid out, but good enough. And then then we set the sprite to draggable. So we say walking guy is the sprite. See, we have sprite with walking guy, 8 frames, 8 frames along the horizontal, along the X, and 1 frame along the vertical. And then we say response to mouse true, set it to draggable, and then set the draggable of the domain to a smaller region of the screen. So it's 0, 0, 200 height. So if you notice, when we try and drag the walking guy, we can't drag it past 200 on the x-axis. We can drag it fully along the y-axis, but along x we can only drag it 200 pixels, and that is because of this domain that we set on that walking guy. Excuse me. Oh, then we build an explosion, 9 again, it was 9 frames. And I need to get this over with. So here we're checking for explosion collisions between the asteroid and the ship. And here we set the asteroid to false. So if there's a collision between a ship and a not dead asteroid, a visible asteroid, we set the asteroid to invisible, making it not appear. And then we call explode asteroid, and we pass in the XY location of the ship. I'm sorry, of the asteroid. So we want to, because what we want to do is we want the collision, the explosion, we want the explosion to occur at the same location of the asteroid that was removed or that collided. So this is why we display an explosion at the location of the asteroid after we've detected that it's collided. And so see here, this one's going to hit it, and then we want the explosion here. This one hit, we want the explosion there, and that's what that bit of code is doing. Here here's explode. So here's a function explode asteroid. We set this explosion sprite to this XY location. We make it visible, and then we explode the sprite. I'm not sure why I commented that out. Let's see if that works. if I get an explosion sound. Yeah, it works. You might be able to hear that on my microphone. I'm not sure why I commented that. That seems important. Anyway, R for reset asteroids, just like before. Here's our key processing. Here's that key pressed. Here's drawing the text on the screen. And then here's our draw function. Set the background, draw the sprites, draw the text. Notice that the explosions, the animation for the explosions, the movement of the automatic movement of the asteroids in the ship, all of that movement is being implemented by this sprites library. So you can hopefully appreciate that there's a lot of capability being provided by the sprites library in terms of maintaining a realistic game with really minimum effort, minimum development effort, other than building the game based on the library itself. All of this physics and movement and frame movement and so on, frame animation, I should say, is all being handled by the sprites library. And this goes over how to do that. I kind of covered it briefly. We'll talk about it more when we get to the game. But this is how we play the sequence. Plays a sequence of frame images. So set frame sequence, and then the first frame to play, the last frame to play, the amount of time between frames, and the number of times to play, which is just once. Or in some cases, we want to do it multiple times. So let's look at the walking guy, just, in for a penny, in for a pound here. When we played walking guy, we're seeing the animation, but it's pretty slow. In fact, you'll notice it's 1 second between frames. Maybe that's why I commented it out. It's too loud. So let's look at that. Build walking guy. And then here we start the loop. And the loop is sent at, I should maybe have this closer, at the speed of 1. So let's set the speed to 0.25 seconds. All right. And we'll run it again. And now you can see his, it's much faster, a little more natural looking, except for that goofy. Let's set it to 0.1 second, a tenth of a second per frame. And then, it's almost a natural looking, a natural looking pace. And again, we can drag them around. So that's, that's an example of how you adjust the speed of the animation, with this property, this parameter, and this sprite has this set frame sequence. And here we're doing it, we're doing it infinite. We don't have a fourth argument, so we're saying repeat the loop, indefinitely. Whereas here, I guess I could point out, if I could find where it is, build explosion. Here we're setting the explosion to twice. Actually, that doesn't make sense. 912. Well, we'll talk about that later. All right. Oops. And then finally, that's animation. Finally, we saw that in SB13, we saw that we could set walking guy to draggable somewhere here. Oh, build walking guy. And so these last 3 lines in the walking guy, building the walking guy sprite, sets the mouse to, clickable. We set it to draggable, and then we set a region of the canvas that constrains where we can drag it. And that's all described there. This other stuff this last couple slides talks about how you can use the world coordinates to create a draggable world where with the viewport can be placed inside a much larger world, so to speak. And it's interesting. Might be useful for a different game or some very complicated version of the asteroids game, but we're not using it for this game I left the slides in from a previous version of this lecture, but right now we're not using this functionality. Well, that's it for the presentation, and let me know if you have any issues.